In this video, we're going to be covering controllers. There are two basic categories of controllers. There's basic RGB controllers, and there are pixel-based controllers. We're going to be going through some examples. I'm not going to show you every single possible one. There are some that are outside the realm. There are other ones that are coming onto the market. There are even other ones that are yet not known. So I'm going to show you some samples, though, to give you an idea of what's available and some of the issues and advantages of each different kind. Now, first on the list here is basic RGB controllers. Now, basic RGB controllers just have the ability to turn off single channels. So, instead of me controlling each individual LED, so if I had this would be a pixel-based module, and I would be able to control on and off this entire pixel. But we may not need to do that. We may want to control a whole string of these as one single set of lights, so that I have just 3 channels, red, blue, and green. I don't necessarily need to control each individual light. So let's take some examples of what that might look like. Now, what we have here, here we have a coral tree, and this coral tree just has, you may be able to see the backside here, has just regular RGB modules in it, basic RGB modules. These are half the price or less than pixel-based modules, because I don't need to be able to control each individual pixel. In this particular element, I don't want that level of control, or do I need it, nor do I need the additional cost. Now, so I've got half the price in the LEDs, and I'm able to build in just a simple DMX controller, which I'll show you in a moment, into the element. So now it's fully self-contained. All I have here is a single cable that comes out, provides power and DMX to this device, pop it in my display, and I'm done. So there's some advantages cost-wise and setup-wise. Here we have a slightly different version. In this particular case, now you can't see this, but in here we have, behind this Coro, we have some RGB strip, just not pixel level, just regular basic RGB strip. It goes up and it goes down, and it goes up and it goes down. And for each one of these sections, we have a DMX controller that's located in the center. And you'll be able to see these wires on the back coming out. You can see the addresses for each individual section. You can see these controllers right here. Now, this has power coming in for 12 volts coming off of a transformer, power supply, and the DMX signal coming in also. Again, this is significantly less in cost than if I were to do pixel level control, and I don't necessarily need it in this particular type of element. I don't need to be able to control each 3-inch section of this wiring, or of this lighting. Now, here's another example. Here's a Coro Star. These Coro Stars, I had about 90 of these in my display this year, and these just have regular old basic RGB modules, and those are driven with this DMX module, which is just attached underneath, 3 channels, and then there's just a Cat5 hookup here coming in and going out, just from Coro Star to Coro Star, just regular Cat5, and then we inject power over the Ethernet cable, so we get power and DMX signal over this regular Cat5 cable. Okay, so there's some advantage here of using basic RGB modules, or RGB controllers. Now, basically everything that you could do with pixel level controllers, you could do with basic RGB controllers. You just lose the ability to control down to that pixel level. So, just like you have a string of lights today that has 100 bulbs on it, and you can control the whole string, basic RGB controllers do that. Now, some things to be aware of when working with basic RGB controllers. First is, some of these controllers are programmed via special programmers. For example, here we have a very tiny DMX, 3-channel DMX controller. That has no dip switches. That is programmed with a special programmer. Here's an example of that type of programmer. Now this programmer right here is used to program this module. or I should say controller. This is a 3-channel, 1 amp controller, and it's just hooked up to regular old RGB modules. These are not pixel based, just RGB modules. And I just inject power and signal over this, and when I want to set its address, I set it with this adapter right here, or with this programmer right here. Another type of programmer used would be this one right here. A little bit larger, AC based. Okay, now, so that's one thing to be aware of. Other types of controllers may have their addresses set with dip switches. Now, in this particular case, this controller has dip switches that allow me to set the address directly. Now, those may be dip switches that go up and down, or they may be rotary type switches that are used, for example, on the LOR boards. Now, here's an example of a smaller version, again with dip switches. Now, there's some pros and cons. Of course, you need to physically get to the dip switches if you're going to be setting them. So if you've got them buried inside of something, it can be hard to change large numbers of these. The advantage is you can look at them. With a little bit of math, you can figure out which dip switches mean what, and you can set them without any kind of external programmer. So you don't need this. Now, the advantage of these is that you can have a sealed module, such as this, that already have the address set. You might write that address on there, or usually you can query the address that's already programmed into it. Okay, so be aware of that. Now, also, there are two basic kinds of controllers in the way that they handle output. Now, they'll either be common anode, usually, which means that we have 4 wires on the output of an RGB basic controller. That means there's 1 positive, common anode, and there are 3 cathodes for red, blue, and green. That means normally on a pixel, on an RGB module, you're just going to have 4 wires. None of these are data, these are just regular old power. So you don't really need to hook up positive, 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 positive for each one of those LEDs. Now, some controllers do that. For example, here we have a LOR controller. This is an LOR DC board, and it does have outputs for each one. Now, in this particular case, I do have it set up so that it actually has the common and the anode and the cathode wired to each one. So it varies, no disadvantages for the most part if you're using any of these controllers with RGB. Okay, now some controllers, depending on where you get them, now if they're tailored towards our market, they may have Cat5 cable connections. For example, in this Tiger 48, we have Cat5 cables, which is what we use in the home holiday entertainment arena. Now, if you're more from the commercial side of things, from the lighting industry, you're going to see these round XLR type plugs. These are the most common on theatrical type devices. So if you've got a moving head or something like that, inevitably they're going to come with these kinds of plugs. So you'd either need to be able to solder something on the bottom, or you could build, like in this particular case, I have an adapter, take some cheap XLR cables, plug it in there, and it gives me a Cat5 connection, which is what will hook up to everything else in a typical display. So be aware, there may need to add in a few extra cents or time to wire in those connectors. Now, others may also have just screw terminals, which in this case allows for us to just hook up simple, easy to use Cat5 cable. And you can see here I've wired up the Cat5 cable again, power and signal off of the same Cat5 cable. All right, now let's go through some of the different types of basic RGB DC controllers. Now, these are DC controllers, so you would need to supply power with a power supply. For example, here I have a waterproof sealed power supply. This is a 3.75 amp 45 watt 12 volt unit. It's completely sealed. I put these right out in the yard, laying in the grass, no problems at all. They're about $8 or $9, and they also happen to be right around the amount that you usually would need to drive a full set of LEDs in terms of power consumption. But you can centralize power, you can decentralize power. We've talked about that. Okay, now let's talk about different types of DC controllers. Now, I'm not going to, again, try to list every possible one on the market today. There are a lot that are out there that I'm not going to mention. I'm going to mention some that I've worked with personally, I have experience with, some that I have passing experience with. Now, some of the comments that I'm going to make will be based on my personal experience and preferences, so be aware of that. Now, to first start off, for a sealed module, we've got a DMX module here, and this is the same DMX module that I have used in my prior items that I just showed you, the Coro Tree, Coro Stars, and the North Star there. This is a sealed unit, so obviously there are no dip switches. We programmed this with a programmer. It's about 50, 60 bucks. You got signal in, power in, 5 volts through 24 volts, depending on the model, and you have 4 wires for common anode output. 4 amps a channel, so it can drive a whole lot of modules. Not completely waterproof, but with proper mounting and sealing techniques, you can have these work well. They have excellent short protection. I've had no failures for the most part. I had some that got a little flaky, but not many in the big scheme of things. These are about $7 a piece. Next, we have a new model that I've recently tried out that seems to be okay. This is a $7 DMX controller, 3 channels again. It has dip switches to set, and it has screw terminals, as opposed to having any kind of flying leads on it. This, I believe, is right around, let's see here, I believe it's about 2 amps per channel. So in most cases, more than sufficient. Again, I've set it up here so that I drive the power and the signal over Cat5, and just hooked up as many RGB modules as I need in that particular case. Now, there are a variety of other miscellaneous DC controllers. For example, here, this controller is on a strip. It's got flying leads. It is the same manufacturer as this square module. It's just in a long form. And it's got an output in addition to an input, power here, signal out, power to the controlled LED devices. Again, no dip switches. You program it via programmer. We've got some others. We have a very small one. Here we can see a 3-channel DMX controller. No dip switches, of course. Too small for that. And it is programmed with a little handheld programmer. Very small. So you can see they come in a wide variety of shapes and sizes. Now we also have one more. Let's see here. What do we do with this? We have, let's see here. Oh, there it is. We have here a little tiny one, and I may have shown this one before. This is a $14 controller. No dip switches because it's 100% sealed. You send a signal with a programmer. Low amperage. I've got it driven here with just Cat5, and outputs here you can see to DMX or to regular RGB modules. Okay, so any of these controllers can control any kind of RGB lighting. So if that RGB lighting is modules, whether it's nodes, because they make nodes that are not necessarily pixel-based nodes. They have strip. For example, here's some just regular strip. This is white only, for example, and this has no pixels in it. This is just regular strip. We would hook this right up to a DC controller. So there are a lot of options there to hook up and drive different types of devices. You can see all the different types that I have here that were shown in another video. Okay, now let's show some others. Let's show you the Tiger 120. The Tiger 120 is a DMX protocol like the others. It comes as either a pre-assembled or soldered together kit. You can get it through a co-op through the Ozzie Christmas Lights group. It is designed around common anode, and you use little connectors to slide in and connect to it. It's usually used with ribbon cable for providing power to your LEDs. To some degree, this has been supplanted by pixels because of the fact that it is 120 channels. Often the wiring and other things involved are more easily done with a pixel-based device. Now, it does control up to 100 milliamps per channel, and it can run some pretty wide voltages of 12 through 48 volts. Now, next we have a Tiger 48. You can see that I've just mounted it in my favorite thing, which is Coro. I've got a power supply up here. This is just screwed to a tree. We've got power coming down here. We've got Cat 5 cables for hooking up Cat 5. Let's show you that. In here, this has screw terminals. So in this particular case, you can see that I've just screwed on lots of Cat 5 because I love Cat 5 for power hookups. I just hooked on Cat 5, and I'm only even using half of this controller. To set the address, you do use a PC-based application, and you just go down here, set the PC application, and then press a button to say program it. It's got some LEDs to show you that it's been programmed, and it does have dual power inputs so that you can put power on one side, let's say 12 volts on this side and 24 on this side. These come either pre-assembled or as a do-it-yourself kit, at least as of last year they were. Okay. Now, next is the Lynx MR16. It was originally designed, hence its name MR16, to drive MR16 LED spotlights. Now, it's 16 channels. It's also set with a PC-based program. You do buy this through a co-op on do-it-yourself light animation. It comes with just a basic board. It does have Cat 5 in and outs. And it uses spade terminal connections for power output, and it has the anode and the cathode for each individual channel. So it's really not designed around RGB per se, especially the fact that it's a higher amperage board, and it tends to be using a spade terminal. Now it's 12 volts only with some adjustments and different components. You can get it to higher voltages. Okay, now do-it-yourself options are not the only options out there. There are LOR controllers. Now here we have an LOR controller. This LOR controller is in here. Again, I have just a power supply. This power supply then provides power down to this LOR board. And again, I just have it running over Cat 5. This is a controller dedicated specifically to running some Mighty Mini floodlights. And it has anode and cathode for each individual output. It is a common anode device so that you do share a common anode, even though they're connections for each individual anode. It's a very high amperage board, runs huge voltage differentials from 9 down to 60 volts. Now, one thing to be aware of, first of all, is that because it's originally designed to be an LOR board, it is set. You've got little rotary switches here that set the address. It does limit you to setting the address. You can see I've got a little map over here as to which channels are which. You have to match up in 16 channel increments. So you can't just dial it into channel 372 to make the start address. So one other thing to be aware of, if you are mostly DIY in the DIY world, we're using E111, what you're going to have is you're going to have to build some DMX adapters to interface between, let's say, Lynx or Tiger or any other standardized DMX devices, because these use 4 or 5 pins in the LOR world, and the rest of the DIY world uses pins 1 and 2 on Cat 5. It does have in and outs, and of course it is a supported board. You can buy it at any time. Now, this also does come in a quick connect version, which replaces the screw terminals with spade terminals. It's a few bucks less. Okay. Now, we also have from D-Lite the DCX16. Now, I should mention, before I continue on, the LOR controller is LOR and DMX protocols. So, be aware, it can talk both worlds, so it gives you some flexibility if you're still on an LOR network. Now, the D-Lite controller, DCX16, is LOR protocol only. Comes as a completely assembled unit. Purchase at any time. It is 16 channels. It's about the same size and design, roughly, of the LOR board, which means that it's just a bare board. You've got screw terminals. You use pins 4 and 5. The difference is that this is a 30 amp board versus the LOR board at 40 amps. It does run from 5 volts through 60. Common anode. Now, for our purposes, be completely aware that this currently, as of today, only supports the LOR protocol. It does not support DMX. All right, so those are the different types of DC controllers that we have. Again, this is not intended to be a comprehensive list. There are many other types of DC controllers out there. And this is not an endorsement of any particular type of controller here. Just samples to give you an idea of what's out on the market. I would highly recommend that you always test anything that you're going to use in your display, or if your vendor supports it, make sure you have assurances that it works with the type of software that it meets your particular needs before you purchase it. Okay, now that we've discussed basic RGB controllers, let's move on to pixel-based controllers. Now, before I continue, I would like to preface this discussion with this is not an exhaustive list of all pixel-based controllers that are on the market. There are some that are high-end commercial controllers. There are others that have yet to be tested. There are others that are in development. There are others that will come after this video is released. This is not an exhaustive list. You will see that other products that may come down the road or other products that are existing today do mimic a lot of the same functionality or design criteria that are the ones shown in these examples that I'm about to present. Now, to start with, let's talk about the TP3244 from Ozzie Christmas Lights, designed by Phil and Tabor. This is a controller released last year. It is roughly about $40. It was last year. It has 4 outputs that allow it to drive 4 independent types of pixels all at the same time. So we can have 6803, 2801, 1804, SD600, all on different outputs. Now, this is purchased during a co-op. They are revamping this board, I understand. And it has, in the past, come completely assembled. You can see there's a lot of SMD devices on here, and it really does limit your ability to, for a lot of people, build this yourself. So, this usually does come as a completed item. It is co-op, so you will need to wait for the co-op to occur. Now, we do set the options on this particular controller via a web-based, a PC-based application. And that just sends the signal to program the device to tell it which pixels, what channels those pixels are going to use over the DMX connection. You can see that it's fairly small in size, which allows it to fit into a lot of tight spaces. It's got some screw terminals for screwing it to a box. Now I have used these, and this is how they were used in my display. What we have here is just a Tupperware type container, them stuck in there, hot glue, 4 outputs to Cat5 cable, and we have power and signal coming in off this cable. So, a cheap alternative, allows me to see inside. Now, it does support up to 512 channels. It supports the HyperDMX protocol, which allows up to 2,048 channels on a single controller. So we could have 512, actually 510, 510, 510, 510 channels output. It does support 6803, 2801, SD600, 1804s, and because this can be upgraded, I suspect you will see it support additional types of protocols in the future. It does support just regular old basic DMX in if you wish to do it that way. Okay. Now, next on the list here we have pixel strings from Do-It-Yourself Light Animation, developed by Robert Jordan. These are purchased as a co-op item. They're designed to be all through-hole construction. Now, unlike the TP3244 we just looked at, which is a more decentralized approach where it has 4 channels all located on one controller, and we would run the power usually to those strips or to the controller or near to it. This works off of a distributed system that's almost like a hub and spoke. It has a hub which you inject power. This power, and along with a signal, is sent out over Cat5 to an individual smart string controller, shown here. That smart string controller runs one string of lights. So instead of you having 4 outputs on a board, you have 1 output per board, but you're splitting the signal at the hub. It includes some other features, including macros. It is unfortunately limited right at this particular moment to an 1804. Now that is my personal opinion. I do like to have the option of more pixel types, more manufacturers, but the 1804 pixel, as we've shown before, does come in all the different varieties. It comes in strip, it comes in module, and it comes in pixel node. So be aware of that. Now, it does work off a proprietary protocol, which has been published. It is supported in Vixen and in Lightshow Pro today. This PixelNet protocol allows roughly 2,000 channels to be sent over a regular DMX dongle. DMX dongle from RJ also looks like this, and it just takes the USB connection. That would be coming from the PC where you're running Lightshow Pro or Vixen and outputs PixelNet on this output port here. That thing goes off to your hubs. All right. Next on our list, we have the E680 controller from Jim St. John of SAN Devices. Now, this device is currently in beta, but it's intended to be an open source design. I'm not sure exactly how much of the design will be released, all the way to the board level, the firmware, the source code. I'm unsure at this time. The pricing on this board, with it were offered assembled, completed, would be in the $70 to $90 range. Bit cheaper if you did it yourself or were part of a co-op. Now, what it is, it looks like this here. What makes this board somewhat unique currently is that it does not take DMX input. It takes E131. So as where on a TP3244 we would run DMX in or the proprietary Hyper DMX protocol into this controller, this actually takes an open standard protocol, which is E131, that is sent over Ethernet. It is sent to this, which has an IP address, multicasted. It is then converted into the individual DMX channels and then output over one of 16 outputs. Now, you should be aware that there are some limitations. You may think that I can put different pixels of each different kind of supported pixel chip on each one of these outputs, and that's not the case. They're actually oriented more like a 4-channel board. This first group is a cluster of 4 individual outputs, and then the next is a 4, and the next is a 4, and the next is a 4. So I can run 2801 pixels, for example, all on outputs 1 through 4. But I could not run 2801s on output 1 and then 6803s on output 2. Now, it does support more types of pixels. It supports the 6803, 2801, the 1804, and you may have heard of something called GE Color Effects pixels. Those are commercially available. They were sold at regular stores, and they had a controller, and if you cut off the controller, you could then run them with this particular controller. They are a little bit more expensive because they're on the commercial side than just regular pixels that we've shown in previous videos. Now, you would need to have an application that supports E131 output to make this controller work. The controller takes the signal, converts it to DMX, and then puts it out across these different outputs. But to get that there, you would need something like Lightshow Pro or Vixen or Madrix or any other type of application that supports E131, which I suspect going forward will be much more common. Okay, now how you configure this is it is configured via a web browser. You just go in. It's got a command line interface currently. You go in, you tell it what you've got hooked up to each one of these, and then assign addresses. It does have some macros built in that allow you to do things like reverse pixels and those types of things. Okay. Now, next on our list is the Color Cosmic ribbon from Lightorama. Now, the Color Cosmic ribbon has been around for a little while. It is pixel strip. There are 50 pixels, 150 LEDs. The item is sold as a combined unit, so you get the controller, the power supply, and the pixel strip that goes along with it. It supports inputs of LOR protocol and the DMX protocol. It does have built-in macros. I can't tell you which particular pixel chip it uses because that is proprietary. And those run about $250, roughly speaking. Now, next on our list, also from LOR, is Color Cosmic bulbs. These are unique in that they are pixel nodes connected to a controller. That controller contains a power supply built into it. Now, unlike the CCRs, which are not waterproof, the controller is not waterproof, the pixels themselves are waterproof. Color Cosmic bulbs, the entire unit is a sealed unit. So what you end up with is your power supply, controller, everything in one unit. So basically it's like a string of Christmas lights. The only difference is that you send the signal to the controller and it controls the individual pixels. Now, what makes this unique in this particular design is that it is using what's called power line control. This allows you to send the signal, instead of over Cat5 cable to the controller, you can send the signal directly over the power cable. So that means that you can get your signal and your power on the same power wire. This is great because if you put them up on your roof, for example, one less cable to put up there along with your power, including the data. You can do that. Now, it also will have regular inputs so that you can run a Cat5 cable to it and then out of it. It does support LOR, and it's believed it will support DMX also. They will come with either pixels that look like pixels that we've shown before, or pixels that look like pixels with C9 diffusers over the top of them, so they look more like traditional Christmas lights. Now, we also have the Firefly from D-Lite. Firefly is a controller, a non-waterproof controller that controls 16 pixel modules. These are diffused modules that allow you to set the controller color any way you want. You can run up to 32 pixels per controller. I don't know what the particular protocol used or pixel chip is used because it is proprietary. And one thing to be aware of here, that only supports the LOR protocol. It possibly may in the future support DMX, but right now it only supports the LOR protocol. Right around the $150 range. Now, there are a variety of other DMX to SPI type controllers. Now, here's an example of one right here. This is from the same manufacturer I showed you the RGB basic controller. It looks almost identical, but it is actually driving, in this case we can see a 6803 pixel node, pixel module, and this is $14, and it just runs one string. So you could use these types of devices. Now you do have to set this particular address using their controller, which I showed before. But there are other different kinds of controllers out there. Here's one that was used early on in a lot of testing. This is a 6803. There's the output for the lights. And then on this side we have, you can see the standard XLR jacks used in more theatrical type lighting. And we set the starting address with a set of dip switches. So there are a lot of different kinds of other adapters or controllers out there for pixel-based devices. And again, there may be more coming. I'm sure there are more coming, actually. So do your homework. Ask a lot of questions. Figure out what's out there before you put down your money